a few things should stand out to us. One of them is, I'm just going to highlight these. She's running 100 meters. It says she's going 19.2 seconds, and she's going to start from rest. So we know that her initial velocity is 0. So if her initial velocity is 0, so we can say, then we know momentum is equal to mass times velocity. So if this was 0, we know the initial momentum has got to be 0. Once she's up and moving, she has a different velocity. So remember, velocity is equal to distance divided by time. So in this situation, we know that she's going to eventually be running 100 meters in 19.2 seconds. So her velocity will soon be 100 divided by 19.2. And that gets us a velocity of 5.2 meters per second. So that's kind of what we're thinking about as the final velocity. Now, you'll remember from earlier in the year, though, this is, we're using average velocity here, so this isn't perfect, but we're imagining she's starting from 0. She's getting up to this 5.2 meters per second. It says that she has a mass of 56 kilograms. So now we're going to say, okay, momentum is mass times velocity, and we're interested in the final momentum here because the initial was 0. So the mass was, her mass is 56, and the velocity is what we just found, which is 5.2. So her final momentum is going to be 291.2, and we're going to put the units there, which is kilogram meter per second. So what's her impulse? Well, remember, impulse is equal to P final minus P initial. It can also be equal to, impulse is equal to force times time, but they're really not talking about force or time at this point. I mean, except for the initial time. So since there's no force involved, we're going to just stick with this equation. So we're going to plug this in. We know our final momentum, which is 291.2. Our initial was 0. So her impulse is going to be 291.2 kilograms times meters per second. Now, it won't always be that easy. It's just particularly easy in this situation because we had this initial momentum of 0 kilogram meter per second. So if it's going to take her 0.2 seconds to kind of reach the speed, now they're asking about force. Now, force is a really good word to pay attention to. It gives us an indication that the problem now wants us to use that other impulse equation. So let's take a look at that. So we have our other impulse equation, which was impulse is equal to force times time. So we actually already know the impulse from the previous problem. It was 291.2, I think, if I'm remembering it from the previous page, is equal to our force, and our time was 0.2. So in order to solve, you're going to divide by, and again, I got that time from right here. Okay, if you're going to divide by that time, 0.2, and we get our force of, 1, 4, 5, 6, and the units for force are newtons.